Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to return to my current project, which is coding the combat system for a game which a viewer is making. In particular, I'd like to talk about what I've done with generating hit points for the player character and the player character's companions, and also how I've started to model distance, which is going to be important because this combat system involves range and distance. So before I do that, I should say that I had been using a new piece of software to record these videos to try and deal with volume problems, essentially, that we've been having. And I've stopped using that software because a couple of times I recorded a whole video and then I found that it hadn't recorded the picture properly. It had sort of frozen and just recorded this single picture, so the whole video was ruined and I sort of wasted half an hour. So we're back to the old software, and as a result we may be back to the old problem. So please let me know if you have any problems with the volume, and I'll do what I can to try and fix it. Anyway, here we are at the start of the game, as we saw not in the last video that I've done in this series, but in the ones before that. In the last video in the series, it just printed a list of the characteristics of all of the weapons that were in the game. But that was never intended to be a permanent feature. That was just a thing that I was doing to make sure that I'd stored the information about the characteristics of the weapons properly and could, extract what I needed when I needed it. So we're back at this screen where we have a choice of who we want to be, and we can change the gender if we want to. So let's be a female influencer, perhaps. This is all stuff we've seen. We have a combat with some enemies. It's giving us their hit points. But on this screen, we have something new. So first of all, we have the hit points of the player. Sorry, I'm trying to just... There we go. Oh, goodness me. We have the hit points of the player character as well as their characteristics, and we have a little picture of the companion. They're called Companion 2 because they're in slot 2. I know it's confusing to have Companion 2 and no Companion 1. And we have their hit points. Now, the reason as a side note, the reason I haven't dealt with that problem, I could probably sort of set up a code so that it calls them Companion 1. In the actual game, they're probably going to be known by their name anyway, so they're not going to be known as Companion 1 or Companion 2. So it's not worth fixing because it's not going to be in the final game. But the point is, we have some new information. The hit points of the main character, the player character, and a picture of the companion and their hit points. And similarly, if we go to this page, we've got some new information. This is old information. It's where how everyone's going to act in order, who's got the initiative. In this case, the enemy 1 has the initiative. But now we've got this new information, which is we've got them grouped by distance. So we have the enemy 1 and enemy 2 are at distance 5, and companion 2 and the player character are at distance 0. Now, I'm not sure if that's how the combat is meant to be set up. I just arbitrarily decided to set it up so that everyone, that the enemies start at distance 5. I haven't been able to find in the document that the person creating this game gave me, I haven't been able to find a rule about how far away they start. It might be in there, and if so, I've missed it. But if this isn't what they want, I'm sure they'll tell me. They've been updating me pretty frequently, so thank you for doing that, by the way. But of course, I had to pick something, and so I decided to just set it up at distance 5. So we have distance 5. It has enemy 1 and 2, and then distance 4, 3, 2, and 1 are sort of empty, and then distance 0 we have the companion and the player character. And in fact, if we sort of go through it again, we will find that that's always how it starts. The enemy's at distance 5, and the player character and their companions at distance 0. Now this isn't intended to be what it's going to look like in the final game. The final game is going to have a visual display, but I found that visual display, setting that up is going to be quite complicated, and so I decided that I wanted to set everything else up before I started on the display. So in the absence of a display, we need some way of keeping track of what's happening so we can make sure that the code is doing what it's meant to be doing. And so I've just done this sort of simple text way of doing it. All right, so that's what it does. Let's have a look at the code. So I had everything going in this horizontal line, but it got wider than the screen, and so it's not very, it was a bit awkward to display. So I've sort of had this sort of spiral thing. I'm not sure if I'm going to keep it like that, but that's what it is for now. We have a single new page, which is print distances, and we have a single new variable, and we have some slots that have been added to a couple of arrays. So let's look at the new variable first. The new variable is the hit points of the player character, and it will be stored in $HP. And then we have an existing array, $com, which is for companions. We have some new slots. We have their hit points. We have the distance from the player character, and we have also their gender, because I wanted to make it random whether they were male or female. That's probably not terribly relevant to the final game, because I think the companions are that you can meet are specific individuals. So like a particular one is always going to have the same gender, I think, in the final game, but I just decided I would do that because I had male and female pictures, basically. And similarly, we have in the array NME, which of course is for the enemies. We have, we already had their hit points. We have their distance from the player character. So you might also notice that I've tried to put the same information in the same numbered slots for enemy and com. So com is type, hit points, distance, gender, and enemy is type, hit points, distance, and then we don't need to keep track of their gender because in the case of these monsters, which are giant mosquitoes, the different genders have different stats. So the type sort of is their gender as well. We can see in the array where we have the attributes of the different types of monsters. They're just distinguished as male and female, and also pupa. So those are those are the new things. We also have an attribute I and some others which I'm going to talk about as we get to them, just in case you've forgotten, because it's getting quite complicated now. And also you might not have been following this series, but even if you have, there's quite a lot of variables now, so we need to refresh your memory as we go. All right, so generating the player character's hit points. The way that hit points work is pretty straightforward. It's simulate rolling 2 6-sided dice and then add twice the strong attribute. And that is true for monsters and companions and for the player character. It works exactly the same way. So we set HP equals random 1 to 6 plus random 1 to 6 plus 2 times ATT underscore PER PER1. What is PER? That is their persona, which is the character class, essentially. And what is ATT underscore PER? That is short for attributes by persona. and that gives, in slot 0, it has the names of the different personas, but it also has their attributes, and slot 1 happens to be their strong attribute. So for example, for a warrior, it would look that up, it would see that they have a strong of 3, so it would sort of simulate rolling 2 dice and then add 6. And then other character types get lesser numbers than that. The warrior is the strongest type, as you probably expect. Doing the companions' hit points works almost exactly the same way, except that instead of PER, we use COM-Z1, because that's where their type or persona is stored. So that's how we generate hit points. How do we display hit points? Well, that's done in story caption, a special title which, whenever you create a page called story caption, as long as the as long as the capitalization is correct, that will execute in the sidebar. So I often use that for sort of the character details, because that's something that's going to continue throughout the game. I won't go through the code that I've already dealt with. This is displaying, what we're looking at here is the code for displaying the different attributes, and then we just have another row, which is the hit points. It's the phrase hit points, then a colon in another cell, and then $HP, the value of the HP variable. So that's pretty straightforward. Displaying the details of the companions is a little more complicated. We have 2 rows in the array. The first row is the pictures. The second row is the hit points. We have 2 variables here, SB2 and SB. We set SB2 to 0, and there's a note there that says set to 1 when and if a companion is displayed used for gaps. So first of all, why are we using SB and SB2 as the variable names when we usually, for temporary variables, we usually use Z, Y, X, W, Z2, Y2, X2, etc. Well, it's because if we change a variable in the sidebar, it will change it for the main page as well. It doesn't separate, say, Z. If I use $Z in here, it doesn't separate that from $Z in the main page. And sometimes, if we're carrying the value of Z forward from one page to the next, that might have an effect that I didn't want to have. It might change the value of something that I needed to keep track of. So to get around that, we have a set of variables that we only use in the sidebar, and then we have the other variables that we use in the main program. And because we're never going to refer to SB or SB2 in the main program, what values they have can't have any unexpected effect in the main program. So that's why and of course SB stands for sidebar. That's why I've chosen those. So we set this to 0. We're going to set it to 1 when a companion is displayed. Why are we doing that? Well, because when we display, I don't want the pictures to be right next to each other. I want to have a little cell that makes a little gap, because I feel that it looks better that way. And we could say, well, let's have a cell that's a gap before every picture. But if we did that, it would be slightly off center, because it would begin with a gap cell and it would center it, including the width of that cell. Now these gap cells are only 2 pixels wide, so it's like they wouldn't be that off center, honestly, but I don't know, it would annoy me, really. That's the main reason. I wanted to do it right. So we have a variable that makes sure that we have a gap cell only before the sort of second and subsequent companions. You can't have a third companion at the moment because there's a maximum of 2, but if we were to increase the number, and that's SB2. And the way it works is we have a loop that goes from 1 to com underscore max, which of course is the maximum number of companions that you can have. And if com SB1 is greater than 0, com something 1 is hit points. So we're looking for a live companion, not a slot that just doesn't have a companion, or where a companion has left, which can't yet happen, but I think can happen in the main game, or where a companion's been killed in combat, which can't yet happen, but that's going to be, of course, something that might happen when we set up the combat. So we look at their hit points and we say, yep, there's a companion there. Or if there is a companion there, then we do everything between that if and that /if, which is, firstly, we say, is SB2 0? Well, the first time that we print a picture, it will be, because we've set it to 0 here. And in that case, we set it to 1. And if it's not 0, then we have this little gap cell. So that ensures that it doesn't print a gap cell the first time we print a companion. It only does it for the second one. And if we had more companions possible, the third one and fourth one, etc. And that means that the array will be properly centered. Okay, this looks complicated, but isn't. Or at least what it creates is pretty straightforward. I'll show you what it does. It'll go square bracket img square bracket art slash att underscore par square bracket com square bracket sb n square bracket 1 n square bracket n square bracket 0 n square bracket. Okay, so that's quite complicated, but not really. It looks in com sb1, and that is the type, or the persona, as this game calls it. And so that will be a number. So let's say it's 2. Then it will look in ATTPAR20, and ATTPAR20, like ATTPAR anything 0, is the name of a particular persona. So we might get, let's say, influencer. So it'll add that to the string. Then it adds a space. Then it adds com SB4, which is the gender, so that might be M for male. Then it adds, although it's difficult to see, there is a space here. Then it adds another space and the word small, .png, n square bracket, n square bracket. So this line will produce something like this. So the way the pictures work, we have the big picture, and we have two pictures for each persona, and we have a male picture and a female picture. So we have warrior m.png, we have warrior f.png, we have scientist m.png, we have scientist f.png, and so on. The small pictures, the ones for the companions, are exactly the same, except they have space small at the end of them. So this is an example of the output you might get from here. It will look in the art folder for influencer space m space small .png, and it will print it. An interesting thing that I discovered is that in the art folder, the names of the personas in the file names are all in lowercase. But this isn't, as you can see, it's not producing any errors. We don't get that broken picture graphic which we get when a web page tries to extract a picture but can't find the picture. So obviously that is okay. It can recognize that influencer with a capital I is the same as influencer with a lowercase I. In other words, it's not case sensitive, which I thought it was. So there you go. That's something I found out today. All right, so that's printing the picture. And then we have exactly the same code. This is the second row of the array, including that we set SB2 back to 0 if need be. And the only difference is that instead of printing the picture, we print HP : space and then the hit points of that companion. And because this code is exactly the same, every time we print the hit points of a given companion, that'll be below the picture of the given companion, which of course is what we want. All right, so that's everything I have to tell you about hit points for today. Let's now look at dealing with distance. Well, as I said, I arbitrarily decided that the companions will... Well, that's not arbitrary. I think it's normal that the companions would start at distance 0, i.e. next to the player character, but I arbitrarily decided that the monsters will start at distance 5. And because of that, setting it up is pretty easy. When we generate a monster's hit points, we also generate their distance. We set it to 5. Similarly, for the companions, when we're generating their hit points and their gender and all that other stuff, we generate their distance of 0. We don't need to generate the player character's distance because we know that it's always 0. That's just sort of how the program works. Printing the distances is a little more complicated because we don't have the characters stored in distance order. We have them stored in initiative order. So, but we want to print everything in distance order. So how do we do that? Well, broadly, what we need to do is we find out the range of distances that we need to deal with, and that takes us down to there. So all this code is finding out the range of distances that we need to look at, and then this is a loop that goes through all that range of distance, and for each range it looks to see if anyone is at that distance and then prints them. So it starts with distance 5. I mean, at the beginning of running the program, it will always start. The range will always be 0 to 5, of course. It will start with distance 5, and it will say, all right, is anyone at distance 5? We'll look through all the companions, we'll look through all the enemies, and anyone that is, it'll print. Then it'll look through, then it'll go, right, distance 4, anyone there? We'll print everyone there. Distance 3, distance 2, distance 1, and then distance 0. All right, so let's look at the code for finding the range. So we set Z equal to 0 and Y equal to 0. I've decided that the highest value for distance we're going to put in Z, and the lowest we're going to put in Y. We set it to 0 because we know that there's always going to be someone at distance 0 because the player character is always at distance 0. And if the player character wasn't around, the combat would be over. So if we're doing this, the player character is alive and therefore someone is at distance 0. Then we have a loop that goes from 1 to Y2. If you've been following this series, you might remember that Y2 is the total number of combatants. The player character, the companions, if any, and the enemies, or the enemy or enemies. We look in the INI array. So this is an array that we've already talked about, but I'm going to refresh your memory. INI stands for initiative, and we're looking in INI X1. INI Z1, as it says in this comment, is whoever will act Zth in the current combat round. So this is everyone in initiative order, basically. And it will either be 0, meaning that that's the player character. It will be a positive number, meaning that it's a companion whose details are in the $COM array. Or it'll be a negative number, meaning that it's an enemy whose details will be in the enemy array. So it looks at that. We set W to be equal to that value because I don't want to type out INI X1 several times. So if W is greater than 0, then that's a companion. We're going to set their distance into V. Whoever we find here, we're going to look at their distance, and we're going to store that in the attribute V. So if it's a companion, we look at com W3. If it's a monster, if W is less than 0, then we look at enemy minus W3 because, of course, it's a negative number. So minus 3 refers to enemy 3, minus 4 refers to enemy 4, and so on. Else, well, if it's not greater than 0 or less than 0, the only other possibility is that it is equal to 0, because the program is set up such that it can never be undefined. And so v will just be equal to 0 because it's always equal to 0. Then we set z equal to math.max zv. In other words, either it keeps its current value or it changes to v if v is higher. And then we set y equal to math.min yv. In other words, it keeps its current value, or if v is lower, it changes to v. Now you might say, why do we have this else set v equals 0 if it's the player character? Why don't we just not do anything if it's the player character? Because z and y are already 0, and so having a value of 0, that's never going to set z higher or make y lower. So why bother doing this bit here? Well, the answer is because what if the first person we looked at was the player character? In other words, what if the player character won the initiative? And what if v had a value that it had carried over from a previous page? Because v is a temporary variable, which means that we might have used v before. I don't know if we have or haven't, but we might have done. And so we might have this value for v, and then when we do this, we might set something to a value that we didn't want, right? V might be 25 or something, and it might set it up so that, oh, well, that's the highest, so we'll set z to 25. And then we get this display with all these distances that we don't want to bother looking at. Now, of course, we could move these to avoid that. We could move these into there and there so they don't execute if it's the player character, but then we've got more code. So it just seemed easier to do it this way. We'll just set v equals to 0, and we'll do this even though it's, in the case of the player character, a bit redundant. All right, so that's setting up the distance, and so now we've got z and y, and what we do with them is we use them in this for loop. We have for x equals z, x is greater than or equal to y, x minus minus, because you remember we have distance 5, distance 4, distance 3, distance 2, distance 1, and distance 0, rather than 0, 1, 2, 3, 4, 5. It just seemed more usual to me to have the player character be at the bottom and the sort of distant enemies be at the top. That's just the way that it's more usual to set things out, I've found. And so we print the relevant distance, and then essentially we go through all the enemies. We have a loop that goes from 1 to enemy underscore max, which is the maximum. Enemy underscore max is the maximum number of enemies that we can have. And we say, well, if the hit points in that slot are greater than 0, that's what enemy W2 is, and their distance is equal to the distance we're talking about, x, then we print enemy W. Then we have exactly the same code for companions, except that instead of enemy max, we're talking about com max, and instead of enemy, the array we're looking at com. This is one example of why putting the same information in the same slots, or the same numbered slots for enemies and companions, kind of makes coding a bit easier, because once we've worked out how to do this for enemies, we sort of automatically know how to do it for companions, just changing the changing the names of the variables that we're looking at. And then for the player character, well, that's even simpler. If we're dealing with distance 0, then we print player character, because the player character is always at distance 0, of course. And that will do what we saw, which is that it will print everyone in order. And as creatures start to move, it'll print them. It'll start displaying them in different places, which letting us know that it's keeping track of things properly. So that is what I've done up to now. The next thing we need to deal with is actions. So the way that we're going to do that, because we have I and I, that array which has everyone in initiative order, we're going to go through that array, and then we'll probably have to split it into 3. We'll probably have to split it based on whether it is an enemy who act automatically, the player character who has a choice of how to act, or a companion who does act, their action is chosen by the computer, but the player can try to influence their actions. The player character can take an action to tell them to do something, and that might or might not work. So we'll probably have 3 different pages, 3 different systems for dealing with actions. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.